to change. So this one, if I find the z-score for 1200, that is going to be too much area, right? I just want the area between. So I'm going to look up, I'm going to make this into a z-score, look up its area and subtract that. Yes? It makes physical sense. So to convert 930, I get 930 minus the mean divided by what do you guys get there?
Negative 0.27.
Negative 0.27. Okay. And then the other one. So the only thing that's going to change for the other one, I'm going to put 1200 in. So what, anybody else get that one?
1.70.
1.70. Okay. So when you look up this, that area is too much. Too much. So what do you get when you look up 1.7? I get 9554. Yeah. How can I put that on there? You have given yourself no room in your little picture. I'm moving this whole thing. All right, stay. And then when I look up negative 0.27, that's this guy. What do you guys get? Anybody? You're all like, you're gonna do it anyway, Joe. You just tell me. Anybody? Yeah, I love you guys. Yeah. Did you get 3936? Yes. Did I get 3936? I said 3936. And then of course, how do I find my area? Oh, sorry. How do I find my area? Yeah, I want to take this much, it's too much, minus this much, and that'll leave me with the amount in the middle.
Oh, you don't find, okay.
What's that?
I did too much work.
Oh no. Oh shit.
So I did 1 minus 0.3936.
Yeah, no. Yeah, you definitely don't have to do that. There's no reason to do that on one of these between problems.
Is it between problems, we always minus them?
Yeah, you get the z-scores, you look up the areas, and then you subtract the areas. Because one area goes all the way down, and you want it to stop. So you just got to cut the rest of that out. It's really visually correct. It's physical. You can it's a physical problem. It's not so like abstract mathy. So whatever the hell this is, I don't know. Somebody can help me out. What's that? 5, 6, 1, 8? Is that what that is? Yes? Okay. So about a 56% chance that somebody would be paying between $930 and $1,200 a month for a 3-bedroom flat in the Taupo district of Waikato, Louisiana. Woo! Okay. So you guys stopped here. I just keep going. Right? How would I do? Where? All right. Can somebody tell me real quick? Look at the 1,200. What did we get 95.54 below it? Isn't $1,200 then in the 95.5 percentile? Because what does percentile mean? The percentage below. So the answer to part B should be very close to $1,200. Do you guys see that? What percentile is 930 in? What percentile is a rent of 930 in?
39%.
Yeah, just a little over the 39th percentile, yes. Because the percentile means that percentage below the thing. So part B is asking me find the rent, the money amount that relates to the 95th percentile. It's going to be close to 1,200, a little bit below 1,200. I'll bet. How would this thing look? 0, what's 0? The mean. What's the mean in? Do a better job, Jeff. Here's the mean. What does z-score look? What's the means?
$966.
Yeah, but what's the means percentile? always, in a normal curve, cuts it in. So it's 50th percentile always, I love it. So the 95th, of course, is gonna be up from there. And I love, some of you guys are like, of course it will be up from there, but trust me, somebody out there doesn't think about that, okay? So it's gonna be up here, 95% below it. How much is above it?
0.05.
Why do we not care?
Okay.
Sorry, no. I did ask the question, so thank you. That was a beautiful answer. Second part, why do we not care how much is above it? Because the chart only cares about the area below. I like it. You guys? Okay. So there's gonna be two steps here. They gave me a percentage. Let me see what you guys think about this. I like this. Let's see what you guys think about this. I just need some paper. Would you agree with me that this first problem, we had an X score, we changed it into a Z score, and then we looked up a percentage? Do you guys basically, isn't that a quick summary of what we did? We did it twice. Well, we did that twice. That's the process.
Yeah.
So if they give me a percentage, the first thing I'm going to do is look at the Z score and then convert it back to an X score. Just going to do that process backwards, right? So normally, if I'm going this way, I use a formula to convert an X into a Z because I'm given an X and then I got to make it a Z so I can look that thing up. So if they give me a percentage, I'm going to have a Z score and I'm going to want to change it back into this guy. That's when we use this formula that we created before. That's if I know a Z score and I want to convert it back into, in this case, a rent. Okay. So help me out. What is the Z score for the 95th percentile? How the hell do you find it? This is a neat one. It's where you get to take a little adventure on a piece of paper. Oh, that's exciting, Jeff. Where's 0.95? The closest I can get to 0.95. Why am I not going to do this? Here we go. 0.95. There you go, Jeff. What's your problem? Crazy dude. There it is, Jeff. Is that right? Is that right? Why not? What is 0.95? Is it a Z-score? Is 0.95 a Z-score?
No.
It's an area. And those are here. I like it. Okay, maybe. Doesn't 0.95 look like a Z-score?
Yeah.
That's the damn little thing trying to trick us. You got to remind yourself, I'm looking at an area, it's in here. So the closest I can get to 0.95, the chart's going to help me out a little bit.
It's 0.1645.
Almost.
No,
You just have your point in the wrong place.
1.645.
There it is, 1.645. So, do you see how it's right between 1.64 and 1.65? Little Jeff with dreams of basketball that were shattered. So, 1.64, 1.65, if you follow the little arrow, it goes to 1.645 because it just splits the difference. It's right in the middle. Does that make sense? And you see a few other places that happens? Yes. I'm going to go off one place. And then the similar ones back there. Okay. So this Z-score is 1.645, but the question wants rent. So we wish the rent was $1.65. Hello. Hello. Is that per second? Excuse me.
You did 1.645 because it was in between 4 and 5.
That's right. So it's in between 1.64 and 1.65. So we split the difference 1.645, right in the middle.
Okay.
I like it. So now I can use this thing, which is the backwards formula, because I'm going backwards. So to get the rent, which is X, I start at the mean. Let's let this make sense. If I start at the mean and I go up 1.645 steps, that is exactly what a Z-score means. It's the number of standard deviations from the mean to the data point. So how do I find the data point? Start at the mean, go that many standard deviations, right? So that's why that formula makes complete sense. I don't know if some of you guys are like, to you maybe. I don't know. You guys, I really hope. Do you guys remember I told you there's going to be one question that's on every test? What's that question? You guys remember? What does the z-score tell you? This is the answer to it. It's going to be sitting on your formula sheet, right? Z-score is the number of standard deviations from the mean to the data point, right? So that answer is just sitting there, written in mathish. Sort of like speak friend and enter. If you know mathish, you can answer that. Yes? Oh, okay. So 95%, right? So I need to know what z-score would I look up that would end up giving me 95% as an answer. So 95% is right between 164 and 165, so it's 1645. That's one of the weird ones where they split the difference because it's right in the middle. That's right. So we know we're on the positive side, yeah. And then, I don't know, what is that? I'm gonna get that.
It's, 1,192 and 5 cents.
1192,
0.05.
5 cents. Don't forget the 5 cents.
If you round up, it's 6 cents.
6 cents then. You know your landlord's gonna round up.
Yeah.
All right, now. Has anyone tried Part C yet?
Yeah.
All right, don't say anything.
Okay.
If you haven't tried Part C, do it real quick. You're gonna run into something weird. Has anyone gotten to the weird part yet? You're like, yes, Jeff, since the first day of this class. It's been nothing but weird. Anybody get that z-score yet? Yes?
4.62.
4.62. What happens when you try to look that up?
It's not on there.
It's not on there. Shit. This chart and I have a disagreement. But I want you to understand. See how it says 3, 5, and up is this?
Yeah.
Do you guys believe that?
No.
Because it's moving up still. It's not collecting a lot, but it is collecting something. So by the time I'm up at 4.62, it's going to be more like 0.9999992 or something, right? So there's two ways you can answer this question. So either you can say, okay, the book says 9999, so what's the answer going to be?
0.0001.
Or I would accept approximately 0%. Because most humans would say anything less than 0.0001 is approximately a 0% chance. So anything off the chart could either be about 100% or about 0%. Or you can just do what the chart says, 0.9999 or 0.0001. Maybe. Maybe. Okay. So it's basically impossible somebody pays more than $1,600 a month for a 3-bedroom in this area. If we do this problem, it turns out to be basically impossible for somebody to pay less than $1,600 a month for a 3-bedroom in San Diego. You guys have that experience. But do you see how these are all basically the same problems? Right, just with different means and different standard deviations. I want to look at this one. Try to do part B on number 2. Oh. So where will the 15th percentile be?
-1.
No, sorry, no, not that specific. I'm just here, just trying to find it on my picture.
On the left.
Yeah, it's
of
gotta
the-
be down here, because that's 50, so I've gotta move down a bit, so there's only 15% below. Percentile is always area below. So I know it's here, somewhere down here. This is 15%. Why did I make this so tiny? I have no idea. So now I gotta look up the z-score that corresponds to that. So am I gonna look at the positive or negative?
Negative.
Obviously, it's below the mean. I like it. And 0.15. It's the closest we can get to that. Oh, Columbus. Sorry. You guys see that? What's the closest you get to 15?
Isn't it?
What's up?
Oh, wait.
Would it be -1.04?
Yeah, because the closest I can get to 15% is 1492 right there, right? So -1.04. That's the z-score. And then I can use this formula to convert it back into a mean, into a rent. I was writing mean, so I said mean. Okay. So that would be, the rent would be 2923.08 minus 1.04 of these.
I thought you added.
Huh?
I thought you added.
Yep, you add, but what's z?
Oh, okay.
I like it. So plus a negative. Math people don't like two signs together. too bad, right? Is even? All right, and by the way, all right. So one thing I want to make sure you understand. Right now, this is just the nuts and bolts of how these things work. The true practical use of this is going to be realized when we start talking about groups of things, not just individuals. For example, how would you try to test a claim? Like somebody says, you can do it, Jeff. Yeah, sure. Somebody says, if you take my course, I can improve somebody's SAT score by 100 points, right? And they go, yeah, my friend Bill took it, his SAT score went up 110 points. Is that enough evidence to convince somebody? No, right? So what would enough evidence be? What would you start to do to start collecting enough evidence?
Start asking people what the difference in their SAT scores.
How many?
Hundreds.
Hundreds, sure, hundreds. I love it. Yes, one person, never good enough to demonstrate anything that's supposed to be just a true statement. I will help you. Well, all you've shown is you can help Bill. So good job. You put together something that can help Bill. He's helped. Are you done? Are you going to shut down now? You better show evidence that you can help a large group of people. Yes? So, this is what I tried to do last time, was to start putting together the nuts and bolts. Right now, we can analyze individual people, individual rents. I pick one person, I pick one thing. But what is most of statistics all about? Isn't it about samples? Isn't it about groups of people? Right? We know this. We know this from day one. It's about groups. So the thing you missed last time, if you weren't here, was exciting. I think everybody who was here would explain it the same way. Maybe I should, would it have been better if I said we went to an island instead of alternate universe Florida? Would you guys have been better with that? So there's an island where the ages look like this. I can't remember what I put here, to be honest. Not to scale. So the ages look like this. So how did I make this picture? I asked somebody how old you are, and I put it down. I asked somebody else how old you are, and I put it down. And then that's how it came out, right? That's chapter 6. The picture I'm looking at is individuals. Now this doesn't work for chapter 6 because it's not normal. It's nowhere near freaking normal. But if I take samples of size 10 from this island, definitely not alternate universe for it, just an island. If I take samples of size 10, this is the part that I was really hoping that would just make sense. The most likely thing to happen is a mixture of young and old, right? Yeah. It's not likely I'm going to get only young people or only old people. The most likely thing is a mixture. And any mixture, when I take an average, shouldn't be close to the real average.
Yeah.
So the real average looks to be maybe 40, even with my crappy ass scale, I don't care. So when I do this, it's going to look more like this. Most of the groups are going to be mixtures. So the most likely sample mean of any group of 10 will be the actual mean. If you just picked a sample of gross month students and you took the average age, wouldn't you expect to be close to the real average age?
Yeah.
Yes. There's no reason you would expect them to be really younger or really older than the average, right?
Yeah.
Okay. If I take 30, that's the magic number. You have no more room on this paper. There it is. If I take 30, my poor man's Batman signal here becomes that.
What do you mean if you take 30?
If I take a sample, let me be careful, greater than 30, and I really want this understood. Everybody was cool when I took a sample of 10, yes? Yes, when we just took a sample of 10 and the most likely thing was a mixture, so the actual average is the most likely sample mean for the samples. Everybody was just really cool with that, yes? If not, let me know. I'll go back.
Okay.
This one, what is this a picture of?
Everyone, right?
Individuals.
So why is there nothing in the 40 and then all of a sudden the 40
This is
goes
just the
up?
way the island is, right?
Okay.
I promise you, I didn't get to the island and then kill everybody that was between 35 and 50 just to make this imaginary situation. I really didn't.
So there's nothing on 40, but then my question is, it shoots up because you're taking the average, right?
Yes, I'm taking a group of 10 people, so I'm gonna randomly pick 10 people. Is it more likely that I get a bunch of 10 people from here, or that I get some from both?
Some from both.
Some from both. So therefore, the most likely sample mean for any group of 10 people I take will be the actual mean of everybody.
Okay,
Does that make sense?
yeah.
Therefore, when I draw the picture that represents groups of 10, so how do I make a new picture now? I take a group of 10, what's your average? Okay, and I put it down. Another group of 10, what's your average? Okay, put it down. Right, and then I go through the island and they're all saying, oh, there's a weird ass guy putting us into groups. I don't know, just look. Then the picture is gonna look like this, probably. I put these little humps because with only 10, it's probably gonna represent these humps still. What's the next most likely thing after a mixture is people around those two peaks, yes?
Okay.
So that's why it's maybe got a little two peaks next to it. And again, I know at this point you're still like, what the shit is my homework gonna look like, Jeff, right? Again, we are still talking about concept. We're not talking about what it's gonna look like for you yet. Is everybody semi-okay with the idea here so far?
Okay.
Now, through computer modeling, they realized that once you get more than 30 people in your groups, when you do the picture of the means, right? So I take a group of 30, get their mean, plot it. Another group of 30, get their mean, plot it. 31, let's say, it's gonna be grade 30. That picture, no matter what the original looks like, the picture will look like this. Or, you know, this general shape.
Okay.
Now, somebody tell me. The mean is 40 in every picture, right? The mean doesn't change. And again, I really want this to make sense. If I took an average age right now of all of us, I would get a number. It's amazing. If I took 2 people, took your average, 2 people took your average, 2 people took your average, 2 people took your average, and then averaged all of those, wouldn't that be the same number?
Yeah.
We're all the same people. I don't group people and we all get older or something, right? Stop, Jeff! Yeah, stop, Jeff! Exceptionally strange. That doesn't happen. I don't think so. All right. Something else. Which picture has the biggest standard deviation? Remember what standard deviation means. What does standard deviation mean? I'll get it started. The average distance
From the mean
for the mean
to the data point.
to all the data points,
Yeah.
right? So what's another way to say it? Something has a big standard deviation if it gets away from its mean more.
So it would be the actual age, the first one.
The first one's got the biggest standard deviation. Now somebody else tell me which one has the smallest standard deviation. The last one, right? Because it stays at its mean more often, yes? And again, an illustration of this is, if you went out and picked one person right now and they were 6'8", that would be a little surprising, yes? Just a little bit. You go,
Yeah.
okay. Randomly pick one person, right? Randomly pick one person, they come in the door like, oh, you're taller than I thought you would be. What if you randomly picked 30 people and their average height was 6'8"? Just a random group, you randomly call people up to come in the door and you're like, what the shit? They're random people. Would that be surprising?
Yes.
So that means it's less likely. So look what this is doing. How likely is it for me to get one person that's like 87?
Pretty likely.
Pretty likely. How likely is it for me to get 10 people that are average age of 87? Less likely. What about more than 30 people average age of 87? Not very likely. That'd be really weird. 30 random people and their average age is 87. Yes?
Yeah.
Maybe. Is it impossible?
No.
Hell no. Is it unlikely? Yes. So, what we need to figure out, so we know this, now watch. Let me see if you guys, this, individuals. These are groups. And these are actually sample means. These are sample means being plotted, yes? Sample means. So look what I'm going to say here. What happened to the mean of individuals versus the mean of all the sample means? What was true?
The mean stayed the same.
Stay the same. So one thing we can notice is the mean of all the sample means is the same as the original mean. Oh. And of course, at the moment, all you have to base this on is what I've said, right? Like, I don't know if I trust you, Jeff. It's just week 8. I don't know, man.
That means we're halfway through, right?
Yes, we're halfway through. It's week. It is week 8, I think. So here's what's interesting. And everybody understand? Does everybody understand what that symbol means? It's the mean of the sample means. That's all that is. It's not divided by x, right? It's a little subscript. The mean of the sample means. I like it. What about the standard deviation? Does that stay the same?
No.
Shit, no. It gets smaller. But is there a formula that shows me how much smaller it gets? I don't know. Oh yeah, there is. So here's the formula, and then we'll do a concrete example showing this. The formula is the old standard deviation, like the one for individuals, divided by the square root of the sample size. Don't worry, it's the first time we're looking at this damn thing, so let's... As n gets bigger, what happens to my standard deviation of the means?
Gets smaller.
Gets smaller, which is exactly what kind of matches, not just with the pictures that I drew. How can you trust me? I'm big math. I love that. I've never said that before. It's like big pharma, I'm big math. How can you trust me? But just think about the concept. Think about why that makes sense. This, why is it exactly divided by the square root of n? That's the one that takes some more math. So take some calculus and then take a statistics course based in calculus, and then you can learn some more stuff. I don't know if that just made anybody want to take calculus. Never know. This is called the central limit theorem, which is kind of funny because as my n gets bigger, what does it look like everything is going to?
The middle.
The middle. So limit is sort of like what happens when I let things get really extreme. So in the limit that n gets really big, everything goes to the center. So that's, I want you to understand why the name is what it is. I affectionately call it the CLT, and I'll sometimes call it chicken, lettuce, tomato. And if I do that, I'm sorry. I've just said it so much now that so it's the CLT. You are now part of a cult, and it's the chicken, lettuce, tomato cult. That's the best cult to belong to. Oh, one more thing here. As n gets larger, the distribution becomes more normal. If n is greater than 30, distribution is normal enough. What do I mean normal enough? Like, we don't know, man. You're the one that said it.
Normal enough to call it normal.
Sure. What kind of problems were we just doing that we got the answers from a specific place?
An individual person?
Yes. And we were using z-scores and we got the answers.
But
We got the probabilities
things
from
weren't
the
normal. Bell box. Bell
chart,
box. Okay.
right? When can you use the z-score chart? If it's normal.
I just love charades.
Sounds like, no, okay. All right,
Excuse me?
maybe yes.
So if n is greater than 30, what's the next word?
Oh, I'm sorry, distribution is normal enough.
Okay.
Yeah, you gotta follow with me. Thankfully, I can still, I told you about that one teacher that is like, what's that right there? And it's like, did somebody remember what I wrote? So whenever I get there, I'm gonna retire. Okay, now, let me ask you this. All right, really, I wanted this to make a lot of sense. Watch this, watch. You watch too. Watch this. Okay. This is like somebody's shirt. I don't know. Weird. Yeah. All right. If I take, look. Let's say I have some data. Let's say I have some data. Let's say that I have 12 ones. Yes?
Okay.
12 ones. And I have 8 twos, and I have 5 threes, and I have, what is that, Jeff? 4 fours, and I have 1 5. Yes?
Okay.
Yes? Oh, let me make it 2 5s. Okay, there we go. Somebody with me? I just didn't want to take all the time in the world, right? Wow. Okay. All right. How many data points do I have?
31.
31. Is this a normal distribution? This?
No.
Shit, no, right? In fact, I can make a really quick, gross histogram, right? 12, 8, 5, 4, 2. Is that normal?
No.
No, but isn't it greater than 30, Jeff?
Yes.
Okay, so what's the key? I really want you to understand this. I don't give a shit how big a sample is. It could look like anything. It could look like anything. So what is it? What were we just talking about then? If I take every sample of 31 possible, that's one sample of 31. It could look like anything. It could look like anything. If I take every sample of 31 possible from a population and plot all the means, that must be normal enough. That will look normal enough. Does everybody get that? We've seen distributions that had n way bigger than 30 that were definitely not freaking normal, right?
Yeah.
So I really want this understood. That's still a picture of individuals. It's only when you make a picture of means of groups that it becomes normal enough when n is greater than 30. Okay, now. Oh man, yes?
So basically you're saying if we had like a bunch of like all possibilities for
Yes.
all those, and you take the mean of all of them, then it would make it normal.
Yes, so let's say I have a big ass, let's say I have 1 million data points and I just pick 31 of them right now.
Yeah.
If I take another 31 and another 31 and another 31 and another 31, I'm trying to, I can't, I don't have improvisational skills, and another one, but another 31, and plotted all their means, that picture would be normal. That ain't anywhere near where this is one sample. This is some lazy dude that I'm going to do one of them. There. That's not normal. Okay, really? I don't know. Okay, now. We're still not doing anything that looks like your homework yet. You understand? So I want you to feel good and bad, I don't know, somewhere in there, but at least it's not, your homework's not going to be this shit yet. Okay. So look at the other side of the one we just did. You too. You look at the other side. Okay. So I've got 4 numbers in a hat. Is everybody cool with the way I chose to display this?
Okay.
Wouldn't each one have a chance of 1/4 so I can make it? Is it really a uniform distribution? Not really, but I'm just I just made these really wide, these things. Is everybody cool with that? Is that a normal distribution?
No.
Hell no, because there's no peak in the middle, right? It is uniform, so it is kind of nice in one respect, but it definitely isn't normal. Now, you could check this. If you put 1, 2, 3, 4 in your calculator, you can get a mean of 2.5 and a standard deviation of 1.118. Cool? Okay. Now, we're going to choose n to be 2. I chose that because I don't want to give you a stack of papers, because can you imagine, look how big this table is for 2. It's not like big. But can you start to imagine what it would look like for 3? So what is this table all about? If you reach your hand in and you take a piece of paper, and then you drop that back in and reach in and take a piece of paper, what are all the possible samples of size 2 you could pick? So couldn't you pick 1 and then 1 again? And then you can pick 1 and 2, so forth. So look, I listed all of the possible samples. Not just one sample. These are all of the samples. You like it? So I had to make a small population. I had to make a small sample size to make it something we could actually look at. Right? Anything bigger, and it's just going to be insane. I'm going to be all over the room, pasting things up with the red lines and shit. I'm not ready for that. Your pen, Jeff. So this picture is, if I pick one paper, it would follow this distribution. If I pick one piece of paper, it follows this distribution. Now I'm going to create, what's the data for the new picture going to be? It's going to be all the sample means. So this is the individual data points. Now I want to figure out all the sample means. That's going to be the new data. So what's the sample mean for this sample? Let's do awesome. 1 and 1. What's the mean?
1.
1. Yes?
Yeah.
I love all of you. 1 and 2.
1.5.
Holy shit. Now we're rocking. 1 and 3.
2.
2. Right? 1 plus 3 divided by 2. And maybe you see the pattern now. 1 and 4. 2.5. Is that cool? All right, keep going. Keep going. I'll catch up to you in a minute. Start to notice a nice pattern. So this keeps going up by half, right? And you'll start to notice this diagonal thing happening because you already did 1, 3 here. I don't know if you guys are with me. Okay. Now, I will admit to this. This is a very small population. I'm taking only 2 things, right? Understand that? I made it nice, 1, 2, 3, 4. But still, what is the most likely sample mean?
2.5.
Which is equal to the actual mean, yes? Okay, I like it. So somebody tell me, how many sample means were 1? Just one of them, right? 1 out of 16, yes? 1 divided by 16 is 0.0625. 2 were 1.5. 2 out of 16 is 1/8, which is 0.1251. So you see how I made this? So before, each individual number could show up once out of 4 possibilities, so they were all to 25%. Now, the most likely thing is 2.5. It's going to be the tallest dude. Right? And then everybody else kind of goes down from there. You can see how it works here. Does this picture look more normal than this one?
Yeah.
Hell yeah. In fact, I mean, this looks pretty normal already. All right. But something even more important is if you guys, anyway, I'm not going to make you do this. If you put this in L1, this in L2, then L1 comes L2, and x squared p of x, did all the work, figured out the standard deviation, you would get this. What did I say it should be? I said the new standard deviation would be the old one, the original one, divided by the square root of n. How big was the samples we took? 2, right? What was the original standard deviation for individuals?
1.118.
And sure enough, if you do 1.118 divided by the square root of 2, if you do that, you get what we got here. Which, thank God, I want you to understand, this would so suck if we actually had to do all this work for every problem. What if it was 80 numbers in a hat, and I was taking every sample of size 5? Can you even begin to understand how big that table would be? 80 numbers, every sample of size 5. 1, 1, 1, 1, 1. 1, 1, 1, 1, 2. 1, 1, 1, 1, 3. 1, 1, 1, 1, holy shit. Right?
Yeah.
Thank God we have a formula that will tell me, if I did all that work, what the new standard deviation would be. Now, I can't stop myself. I'm going to call this the new standard deviation. It is the standard deviation of the sample means. It's not new. The other one isn't old. Right? The original one is for individuals. This one is for groups. So listen. I know we did a lot today. If I ask a question about the probability that one person or one thing does something, I want a distribution of individual things. Does that make sense? I want to compare one person to all the other one peoples and see where they fall. If I say, what's probably this group of 31 people do something or somewhere, I got to compare them to all other groups. So if I have a standard deviation for individuals, it is not going to work for a question about frickin' groups. Does that? Sorry, I know it's a lot. Okay. All right. So let me do one more thing, and then we're going to have most of our actual work next time. Do I have any more paper? Just any paper. You have paper? You have sort of paper. Yes, sir.
So n is the sample size, right?
Yes, n is how big each sample is I'm taking, yes.
Okay, and this is, which chapter is this?
This is chapter 7.
Okay.
Yeah. So very quickly, I want to give you an example problem. If we know that the mean of something was 1, and the standard deviation is 3.9, we take a sample of, what do you have, 50 data points. I want to know the probability that the sample mean is more than 21.
3.9?
Sorry? 3.9, yes. That's 3.9. Okay. The first place this problem sounds different from chapter 6 is in the question. That's the first place it sounds different. Something else too. Even if I asked you, probably one person, what do I not say in this problem that would normally mean I can't do anything? What do I have to know before I can use the z-score chart?
The mean.
True, but more, what's a good word? Yeah, we have to know the mean, we have to know the standard deviation to do anything. I agree. But
We have to
before
know
I
it's
can use the
normal.
z-score chart, I have to know it's normal. Do I say this is normal anywhere?
No.
No, not directly. But what do we know is true? I'm talking about a sample of things, yes? How big of a sample?
50.
And that is more than
31.
more than 30. So central limit theorem says normal enough. So
Applies for all.
Any situation where we're taking samples and talking about the means, yes? What tells me this is gonna be a divide sigma by square root of n kind of problem? The fact that I took a sample and I asked about the sample mean. So what kind of picture do I need? I need a picture that represents how all the groups of size 50 are distributed. The one that represents all the individuals, what the shit, that has nothing to do with my problem. I'm talking about a group of 50 people. So this standard deviation they gave me, that is for individuals. How do I change it into the one that works for groups of 50?
Oh,
Yep. Just by that. So what is it that told me to do that? I can't just draw the picture and get a z-score. I have to first do this. What tells me to do that? I took a sample. I asked about the sample mean. That means I can't use the stuff for individuals. I need the stuff for groups. So if I do this, what I'm doing is I'm taking the old standard deviation that worked for individuals and I'm changing it into one that works for groups of 50. What is that? 0.5612?
0.5515.
That's pretty good. 551565552. Now watch. I mean, you've been through some shit. You've been through so much shit with me. We went to Alternate Universe, Florida. We've been taking people, throwing them around, all this kind of stuff. You're gonna love this. So this is the only new thing we've done so far. Now watch. Draw the picture. What goes in the middle?
20.
20, because that's the mean. Still the mean now. What data point am I curious about? What's the problem? Greater than 21, right? So here's 21. Greater. I want to make this into a z-score, yes? Everything we do now is going to be the same as before. I just can't use 3.9. I got to use 0.552. So how do I make a z-score?
Look at the chart.
Nope, I don't. Once I get a z-score, I can look at the chart. How do I make a z-score out of this?
Okay.
So 21 minus
20.
20, the data point minus the mean, divided by,
The standard deviation.
which is?
0.552.
Excellent. That'll be about 1.91. I don't know. It's probably a lot less than that. 1.87?
Yeah, that is so much less than that.
1.62? That's too less. I don't know.
1.81?
Oh, I was close. 1.81. So you guys get it. Then guess what? You look it up. You get that area. You do 1 minus. See, I mean, what was the? Oh, no, I love you guys. I have no idea how you're gonna feel about this. Over the course of 2 days, we talked about Florida. We talked about islands. We talked about all this shit. I gave you a thing. There's got a lot of colors on it. I talked about shit and so forth. The only new thing in your work is changing the standard deviation at the right time. How do you know when to do it? Take a sample, and I ask about the sample mean. That tells you to do that, and then everything after that is the same as chapter 6. It's crazy. So what do you get when you look at 1.81? Yeah, 9649. I like it. So that's 9649. So this will be 0351. All right. Some of you guys look like I have beaten you. I'm sorry. I sort of have. But please, I hope somebody likes the fact that after all that weird shit, what your problem's gonna look like. Basically the same as chapter 6. The whole thing with statistics is all about very simple kind of formulas, very simple little adjustments, but you just have to know when those happen. That's really the big thing with stats. That's enough. So Tuesday, I'll have a practice test. We'll have the quiz, of course, chapter 6. Yes.
Are there only 2 formulas we should be worried about for chapter 6?